Hello there, Mr. Sutton here, bringing you the IM3 Honors 3-2 lesson on adding and multiplying complex numbers. As the title suggests, we're going to add and also subtract complex numbers. Can't leave out subtraction. But then, yes, we are going to multiply these complex numbers.
Before we dive into the warm-up, we should probably define what complex numbers are. So complex numbers are anything in the form a plus bi, where a is a real number and bi is an imaginary number. So some examples of this, you might have 4 minus 4i. So 4 is the real part, negative 4i is the imaginary part. You could also have something like 0 plus 4i, and this would actually just be written normally as 4i, just as an imaginary number, but it counts as a complex number with a real value of 0. And just as another weird example, if you had 4 plus 0i, that would also count as a complex number, but of course you would just write this as 4. So what comes out of this is that complex numbers actually include all the imaginary numbers, all the real numbers, and all of these plus or minus combinations of reals and imaginaries. So with that said, let's do a few examples here. For these examples, you need to simplify. You're just going to basically be adding or subtracting these complex numbers together. And as a little bit of a hint when you do this, what would you do if this were just x instead of I involved in the problem? So pause the video and try out this first one. Just do whatever you think you need to do. All right, so for this one, just like when we are simplifying x's, like if this were negative 10 plus x plus 8 minus 4x, we would get rid of those parentheses first. And since nothing other than 1 is being multiplied by them, we can just write this as negative 10 plus I plus 8 minus 4i. Now at this point, what do? Well, if these were x's, we would just combine like terms. And in fact, that's exactly what we have to do here. You just treat I like a variable when you're combining the like terms. So let's do the reals first. Negative 10 plus 8, that's going to add up to negative 2. And then I plus negative 4i, well, that's just going to be negative 3i. And this is the simplified answer to that. So now that we've got one of these under our belt, pause the video and try this next one out. All right, so this one was a little bit trickier because we had this negative parentheses. So this first parentheses can go away pretty much for free, just 6 plus 7i. But we have to distribute the negative to the next one, negative 1 being multiplied by all that. So we could write minus 2, and then, careful here, minus 4i. The negative 1 gets distributed to both of those. And then combining like terms, 6 plus negative 2 is 4, and 7i plus negative 4i gives us positive 3i. On this particular example, we're being asked to simplify the sum or difference of all these different powers of I. Now, if you're just thinking about simplifying I in terms of combining like terms, you might look at this and say, well, they all have different exponents. None of these are like terms, so I'm just done. I just rewrite the problem and I'm done. In fact, though, we know that we can simplify every power of I above I to the first. So on these problems, you really do need to simplify all powers of I before combining like terms. So we've done simplifying powers of I before. Pause the video, do that, and then see if you can combine the like terms at the end. All right, so going through these one at a time, again, to simplify powers of I, you need to know where you are in that cycle of 4. So 43, if you divide that by 4, you get a remainder of 3. So this can be written as 10i to the third. For 29, dividing by 4 would give us a remainder there of 1. So this would be minus 89i to the 1. And then here, 50, well, 50 divided by 2 gives us a remainder of 2, since 4 goes evenly into 48. So this is negative 75i squared. Now that we've got these simplified to at least the power, the place we are in the cycle, let's go through and simplify a little further. 10 times I to the third, well, I to the third is really negative I. So this is really negative 10i. And for this next one, I to the first is just I, so we can write minus 89i. And then for this last one, we know that I squared is really negative 1. Negative 75 times negative 1 gives us positive 75. And at this point, when you only have i's, like I to the first power, and constants, you can combine like terms. So we had to do a little work before we could combine anything. But here we see that we have a negative 10i minus an 89i. So that's going to add up to a negative 99i. And if you want, you can put the 75 out in front. Here's another example involving this time multiplying complex numbers together. So pause the video and give this one a shot. Let's see what you come up with. All right, so there's a few ways you could go about this. If you wanted to, you could simplify these powers of I before multiplying, like we did before we added things that had powers of I. But really that doesn't make a whole lot of sense here, because when you multiply these i's together, you're just going to get some other power of I. You might as well just wait until then to simplify it. So I've got 12 times 3. That gives me 36. I to the 5th times I to the 10th. Well, using my exponent rules, I have to add those. So that's going to be I to the 5 plus 10, or I to the 15th. And now that I've just got a single I to a single power here, at this point I'm going to figure out where I am in that cycle of 4. You could have done this earlier, but I feel like it's less work if you wait until this point. So 15, if you divide that by 4, that's going to be a remainder of 3. So this is really 36i cubed. And we know that I cubed is really negative I. So this is just negative 36i. For this next set of examples, we are multiplying complex numbers together that are a little more complex than what we did before. These have both non-zero, real, and imaginary components to them. So pause the video and see how far you get on example 5. Now, example 5, if we were just doing this with x's, then we would just go ahead and multiply this out, or FOIL this out if you like. Basically distribute everything in the first parentheses to everything in the second parentheses. And we're actually going to do that exact same thing here. So this is going to be just like doing it with x's until we get to the very end. So we have 3i times I. That gives us 3i squared. 3i times 4 is going to be plus 12i. And then negative 5 times I is negative 5i. Finally, negative 5 times 4 gives us minus 20. And at this point, we have to be a little bit careful, because we know that any power of I above I to the first can be simplified. So I squared, we know that's really negative 1. So I'm just going to rewrite all of this with a negative 3 out there. And at this point, I can go ahead and combine like terms. So negative 3 minus 20, that's going to give me negative 23. And by convention, I always put the real number first. And then we have a 12i minus a 5i, giving us a plus 7i. All right, pause the video and give the next one a shot. Now, on this one, you can take a little bit of a shortcut. You might recognize that these are conjugates. We have the same terms, but with opposite signs. So we can use the a squared minus b squared shortcut on this one. Squaring the first thing, we get I squared. Squaring the second thing, we get 25, and then we're subtracting that. So minus 25. And we know that I squared, again, is negative 1. So this is really negative 1 minus 25, which simplifies to negative 26. For this last example, we're trying to multiply two radicals together. The only catch here is that the stuff inside the radicals is negative. Is that a game changer? Well, let's find out. Pause the video and go ahead and do this the way you think it should be done. All right, did you end up with negative 60? Well, in that case, you're absolutely wrong. So we got to be careful with these negatives inside. As it turns out, you have to take out the i's before you multiply, or your answer might have the wrong sign on it. Hey, that's kind of catchy. Take out the I before you multiply. Right? I think make that into a song. Anyway, let's go ahead and do this. So we've got a negative here coming out as an I, so negative 2i, radical 3. And now we're multiplying by 5i, radical 12. So let's multiply the outside stuff. Negative 2i times 5i. We can initially call that at least negative 10i squared. And then the inside stuff, 3 times 12 gives us a radical 36. Well, I squared we know is negative 1. 36 square root we know is 6. So we have negative 10 times negative 1, which gives us, positive 10. Times 6 gives us positive 60. And we got negative 60 if we just multiplied this straight out without taking out these i's in the beginning. So yeah, that's how we got to do it. Take out the i's before we multiply. For the wrap-up here, pause the video and take a moment to write down a little bit, comparing and contrasting, adding and multiplying with normal variables versus variables that have I in them. How is it the same? How is it different? Adding and subtracting with variables versus I, multiplying with variables versus I. All right, so with adding and subtracting, it's exactly the same. Doing it with I or X, you do the same stuff, combine like terms. But when you're multiplying with normal variables, you don't have to simplify X squared to anything. You do need to simplify I squared and every power of I higher than that as well. So that's the main difference, is when you have powers of I, they can always be simplified first. So, is it my imagination, or is this lesson over? It is indeed. Till next time, Mr. Sutton signing off.